is a circle of radius 1 that is centered on the origin. So because that circle is centered on the origin, obviously this point is just going to be 0, 0. This point is going to be the point 1, 0. This is going to be 0, 1. This is going to be negative 1, 0. And this is going to be 0, negative 1. Now, when you rotate around the unit circle, you rotate in a counterclockwise direction. Whoops. When you rotate in a counterclockwise direction, you're rotating in the positive direction around the unit circle. When you rotate in a clockwise direction, you're rotating in a negative direction. So, if you think back to the quadrants, which I think you have talked about, we did talk about the quadrants a little bit in Algebra 2 even. The reason that the quadrants are numbered as they are is because you always start at the point 1, 0, that's 0 degrees, and you rotate in the counterclockwise direction. So as you're rotating in the counterclockwise direction, you go through quadrant 1 first, quadrant 2 second, quadrant 3 third, and quadrant 4 fourth. Also, as you're rotating around the unit circle, you'll notice that you start at the point 1, 0 at 0 degrees, and you rotate a full 90 degrees to the point 0, 1. You continue to rotate a full 180 degrees to the point negative 1, 0. And then you continue on your path around the unit circle to 270 degrees, and then as you continue back to where you started, you get to 360 degrees. That is why whenever you hear like skateboarders talk about 360s, they turned themselves around 360 degrees. They did a full circle. So those are the units that you're used to working in, is degrees. But what we're going to be working in this book is in radians. And hopefully you have a little bit of practice converting degrees to radians. If not, we're going to do a little bit of practice with that right now. What you're going to do to convert degrees to radians is, first what we're going to do is we're going to talk about what is a radian. The circumference of a circle is 2 pi r, right? If we wanted to find the circumference of the unit circle, this unit circle, the radius is 1. So it would be 2 pi times 1. So the circumference of this circle is 2 pi. Okay, radians measure the distance around the unit circle, okay? So as you travel around this unit circle, we're going to cover 2 pi radians because the circumference of the circle is 2 pi radians. So let's go ahead and fill that in right here. As you go all the way around the circle, we've gone 2 pi radians. With that being said, can you see that if you go halfway around the circle, that will have been 1 pi radians? So that'll just be pi. Now, if you think about it, if you go a quarter of the way around the circle at 90 degrees, that 1 pi is going to be split into 2. So at 90 degrees, you have pi over 2 radians. And likewise, if you continue, so you go from 0 radians to pi over 2, 1/2 pi, all the way to pi radians, and then we're going back to 2 pi, but halfway between pi and 2 pi is 1.5 pi. So this is going to be 3 pi over 2. So that's where the main radians are located on the unit circle. Now, that is if you're operating in the positive direction. Now, let's think about what happens if we're operating in the negative direction. If I asked you to locate negative pi over 2 on the unit circle, you're going to go in the negative direction. And when you go in the negative direction, I guess I'll still do this in red. This 270 degrees, or 3 pi over 2, is the same thing as negative pi over 2. Continuing in the negative direction, pi is also the same thing as negative pi. And then pi over 2 is also the same thing as negative 3 pi over 2. And then over here, 2 pi is the same thing as negative 2 pi. So now, what happens if you have an angle that is not, one of the right angles of the unit circle? Let's think about what happens if we split pi over 2 exactly in half. If right here is 0 pi and right here is 1/2 pi, wouldn't you say that right here we have pi over 4? So as we're building our unit circle, we've got 0, we've got 1/4 pi, pi over 4. We move to 1/2 pi. So now as we skip from 1/2 pi to pi, wouldn't you say this would have to be 3/4 of pi? Which is 3 pi over 4. So now let's count again. We've got 0, we've got 1/4 pi, or pi over 4. We've got 1/2 pi, or 2 pi over 4. We've got 3/4 pi, or 3 pi over 4. Now we've got pi, 4 pi over 4. So wouldn't you say down here we're going to have 5 pi over 4? And then as we move this direction, well, okay, so we have 5 pi over 4. Then down here we've got 6 pi over 4, which reduces to 3 pi over 2. And then right here we go to 7 pi over 4. And then we go from 7 pi over 4 all the way back up to 8 pi over 4, which is 2 pi. Now, that's great and all, but now we wonder, what does pi over 4 represent? Even if you know what pi over 4 is, if you can't figure out really what it represents, then it's a little bit more difficult to solve a problem with the idea that not knowing what pi over 4 represents. So, at least in the beginning, you're probably going to need to convert to degrees a little bit, just until you get used to the way these radians work. So let's convert pi over 4 radians, pi radians over 4 to degrees. Okay, if you think about it, pi radians is the same thing as 180 degrees. So we can set up a little comparison here. We say pi radians over 180 degrees, and if you can get radians in the numerator and the denominator, you can cancel radians. You can also cancel pi, and you get 180 over 4 degrees, which reduces to 45 degrees. So pi over 4 is the same thing as 45 degrees. Same thing if you want to convert, let's say we want to convert 100, let's say we want to convert 45 degrees back to radians. If we have 45 degrees and we want to convert that to radians, we write 45 degrees, and then we compare 180 degrees is the same thing as pi radians. You can cancel your degrees out. Whoops. When you cancel out your degrees, you get 45 pi over 180 radians, which reduces to pi over 4 radians. So that's a little introduction to really how the unit circle works. And now what we're going to do is we're going to work through a couple of problems using what we know about the unit circle and kind of show you how we apply these problems. So first, we are going to look at first we're going to look at finding the terminal point on a unit circle. What that really means is basically as you rotate around the unit circle, where the terminal point is where you're stopping. and you stop, you're going to be given a distance in radians, and you're going to ask to figure out what that distance in radians refers to and where would you stop on that terminal point. So, for example, problem number 1 gives you a terminal point t equals pi. Okay, so if we want to find the terminal point on the unit circle at t equals pi, that means that we are going to rotate around the unit circle pi units. When we rotate around the unit circle pi units, do you see that we land on the point -1, 0? So the terminal point for a unit circle, terminal point for t equals pi will be -1, 0. Let's look at t equals 6 pi. We have to rotate around the unit circle 6 pi times and see where we land. So we rotate 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. And at 6 pi you land right back at 2 pi, which is the point 1, 0. So 6 pi is going to be 1, 0. How about -3 pi over 2? -3 pi over 2 means that you're going to rotate in the negative direction 3 pi over 2 units. So we go the negative direction to -pi over 2, -pi, and -3 pi over 2, which is the point 0, 1. Okay, well, what happens if we want to find a point that is not at on one of the axes of the unit circle? Then it gets a little bit more difficult. For example, what if you want to find